do one problem on the file that has to do with nonlinear systems. You have all of the ability that you need to learn this. It's just a step-by-step process on this. Okay, so I'm going to go ahead and just kind of take you through these two problems, and we'll kind of see how this goes then. All right, so what you do first, step one, is you pick either equation and you solve for either variable. So you can solve for, X or Y, it's up to you. But you want to keep this as simple as you possibly can. This second equation is easier to work with because it doesn't have a second power on it. So what I'm going to do on this problem is I'm going to choose that second equation, and I'm going to write it down. That's x minus y equals 0. Now, you can either solve for x or you can solve for y. It doesn't matter which one you want to do. What I'm going to do on this one is I'm just going to solve for y, and you can do this or solve for x. Okay, so we could do that. To both sides, you get x equals y. That's step one, is pick an equation, solve for a variable, and pick the easier equation. Don't do it the hard way, okay? All right, step two is you're going to plug into the other equation, okay? Plug into the equation you did not pick, okay? So what I would do is I'd do this. I would write down that top equation, x squared minus y equals 6. Now, it doesn't matter which way you plug this in, but this is basically saying x is y. So if I want to, I could change x in this problem to y. I'm just plugging it in. That's what it says, x is y. So we want to have an equation with one variable. All right, that's what our goal ultimately is, to get this down to one equation with one variable. Okay, so I'm going to replace that x with y. So then I get y squared minus y equals 6. Okay, do you guys see what I've done so far? Okay, pick an equation, solve for a variable, plug it in. Now, do you guys know how to solve this equation right there? That's a quadratic equation. So what do? You get one side equal to 0, right? So you need to subtract 6 from both sides. You don't have to show that step because you're just moving the 6. Now we have y squared minus y minus 6 equals 0. Now, when you solve a quadratic equation, it's either you go through and use the quadratic formula or you factor. Factoring is the smart way to do it because it's less work. You always want to do things with the least amount of work, okay? So we just draw two parentheses. We got y and y, and we'd have 2 and 3 to get 6. Okay, and the outside term be 3y. We're trying to make that add up to that middle term, negative y. So how do you make 2 and 3 add up to negative 1? Thank you, negative 3 positive 2. Okay, so we got that. Okay, and we've been doing this kind of factoring equation a lot all semester. So you can tell me what the answers are in your head now, I think. Y plus 2 equals 0. That gives y equals negative 2. And then you have y minus 3 equals 0. That gives y equals 3. Now, that's not the answer of the problem. That's just what y is. Okay? You got to also go back and find what x is. Okay? So that would kind of lead us to our step 3 here, is we need to find x for each y. Okay, all right. So watch carefully how I do this. Now, you can go back to either equation, either the top equation or bottom equation. If it's me, I'm going to the bottom equation because it doesn't have a square in it. It's easier. So let's just write down that bottom equation as it started off, x minus y equals 0. Okay, now all you got to do is you got to do this. If y is negative 2, as we got that answer, y equals negative 2, then just plug it in and find x. So that would give x minus negative 2 equals 0. That gives x plus 2 equals 0. So that gives x equals negative 2. Okay, now you're going to get points. So you write your answer like this. You say negative 2 is for x. That corresponds negative 2 for y. So that right there would be one answer to that problem. The answers are points on a system of equations. Okay, so that's one answer. The other thing you got to do is you need to now do the other y. The other y was 3. So if y is equal to 3, well, you just plug into that equation to get x minus 3 equals 0. So that gives x equals 3. Okay, so that means that when y is 3, x turned out to be 3 just also. So the second equation, or the second answer is 3, 3. Okay, there's a lot of work goes on in that problem, but that's the strategy you go through, is solve an equation for a variable, plug in, and you're typically going to get 2 answers. Not always, it just sort of depends on the situation. That's a lot to kind of follow on that, okay? Do we have questions?
Makes sense.
Make sense?
On the equation, it says y equals x.
So we could have done that, couldn't we?
Like,
boom. Yeah, I just chose not to do that. But what he's saying is a really good point. When we solved this equation, we had x equals y. What does that mean? That really means x and y have to be the same number. And they did turn out to be the same number. -2, -2, 3, 3. So you could have done that. Okay? All right, I thought if I explained it that way, it'd be more confusing. But it's less confusing, probably. So I'm glad you brought that up. Okay? All right, let's do number 12. We need a little bit of practice on this. So, all right. So we have 2 equations, got x squared plus y squared equals 5, which is a circle, and we get x minus y equals -3. Step 1, pick an equation, solve for a variable. Do you want me to pick the top equation or the bottom equation? Bottom. Why would that be the best choice? It's easier. There you go. Good. Doesn't have any second powers in it. So we're going to pick x minus y equals -3. Do you guys want me to solve for x or solve for y? I could care less. I think x is easier. So, I mean, yeah, you could add y to both sides. Again, there's several ways to do these problems. So if we do it this way, we just get x equals y minus 3. Okay, pick an equation, pick a variable to solve for, and keep it simple. Okay, step 2. Write the other equation. So write the equation you haven't worked with yet. Okay, just write it down. You've got x squared plus y squared equals 5. Okay, now how do you plug in? Well, we figured out what x is. So you replace x with y minus 3, because you want to end up with an equation that's got one variable. That's the idea. Okay, so we solve for x, now we plug that in. So now what you're going to have is substitute that x, change that x to y minus 3 to the second plus y to the second equals 5. Like that. So see, what our purpose is to get this down by substitution, to get it down to one equation that's got one unknown. Does that make sense? Okay, that's a quadratic equation. What do I need to do to solve this equation I've got on the board? I got y minus 3 squared. What would be a good idea for that part of the problem? FOIL it, multiply it out. There you go. Okay, so let's go ahead and FOIL that out. Write it out twice, FOIL it out. Because it's a quadratic equation. A quadratic equation, you always got to get one side equal to 0, everything all multiplied out. So if you FOIL, you're going to have y squared minus 3y. Inside term's another 3 minus 3y. Last term is positive 9. So we've got that. Okay. What next? What do you see?
Would be 2y squared minus 6y.
Good. Like terms. Good. So we got 2y squared. And I think I heard you say minus 6y plus 9 equals 5. Okay, now what? Get one side equals 0. Right. Good. Okay. So do that. So you're going to get 2y squared minus 6y plus 4 is equal to 0. Okay. And I'll tell you one thing that will happen on this final a lot. The most common thing that's going to pop up is quadratic equations. Okay. I mean, it's going to be on there in several problems. So now you can either go to the quadratic formula or you can factor. Factoring's less work. That's always the way I look at the problem. you can factor a 2 out because they're all even numbers. So if you take a 2 out, you would have y squared minus 3y plus 2 equals 0, like that. Okay, and then that thing in parentheses does factor, so you just bring the 2 down, and when I factor what's in parentheses, I'm going to have y and y to get the y squared, and to get the 2, I'm going to have a 1 and 2. Okay, how do I make the middle term 1y and the outer term 2y? How do I make that add up to negative 3y? Negative, negative, because they got to add up to that term right there. Okay, so we got that. Okay, now you can do this in your head if you want to. You don't have to write all this out. What are the 2 answers to this equation? What? 1 and 2? Okay, what do you do? Don't worry about the 2. That doesn't matter. This is y minus 1 equals 0. That gives you y equals 1. You have, remember, after you factor, you set each factor equals 0. So this right here gives you your 2 y values like that. Okay, so you plug in, you get in step 2, which is the big part of the problem, is you solve the equation after you've plugged one into the other. All right. Okay, step 3. I got to find the other variable, so I find x. Okay, and you can plug these y values into either of the original equations. The easiest way to do this to me is you already solved this equation for x. Now you just plug in. So one of the answers was y equals 1. The other answers was y equals 2. Just simply plug it in. So you're going to get x equals 1 minus 3. So x equals negative 2. Okay, so that gives you one answer, which is a point, negative 2. When y is 1, we figured out that we get x equals negative 2. So that's answer number 1 right there. Okay, the second answer, again, we have x equals y minus 3. Plug in, you get x equals 2 minus 3, so that's negative 1. So x is negative 1, y is 2, like that. Those are your 2 answers to the problem. Okay, now that to me is algebraically, that would be one of the more difficult problems you do on the final. To me, that's got a lot of steps. It's got a lot going on. That to me is a pretty big problem. But it's got a 3-step process. Essentially, it's plug one equation into the other, solve. Then once you get those 2 answers, find the other variables. That's what you're doing. Okay, what do you guys think? I can't tell. Okay, all right. Okay, and I would certainly, before you take your final, I'd run through those problems and see if you can do them yourself without staring at my answer key. That's the key on this. You got to be able to put it together yourself. Okay, all right. So I'm going to jump down to the only other thing that I have not shown you is this will go to 26 and 29. Now these problems right here, I'm going to teach you how to do these on your calculator. And you're going to be able to use your graphing calculator for the entire final. Okay, so the good news about the final, I had you all do 2-part tests, and the purpose of that was to see if I could get you to do graphing without totally relying on your calculator, which is worth it, I think, for higher math. On the final, we let you use the calculator on the entire thing. So first of all, let me kind of show you what you want to do. You want to have one side always equal to 0. Okay, so this is kind of like a quadratic equation. It's not an equation, it's got less than and greater than symbols. Okay, step 1 is to subtract 15 from both sides. Okay, so just write that as x squared minus 2x minus 15 less than 0, like that. Okay, now you could go directly to your calculator, but let's go ahead and let's factor this right now. So you're going to also see on your final exam, factoring is going to pop up a bunch. Okay, so the first term is x and x. for 15, what do I use for 15? What are the numbers that multiply to give 15? 5 and 3. Okay, doesn't matter which order. Okay, and then what you have is you got a 5x, got a 3x. What are you trying to make 5 and 3 add up to? -2. Okay, good. So how do you make 5 and 3 add up to -2? There you go. Excellent. Okay, so we got that. All right. Now, you don't have to write this step out because you can do this in your head. But what's going to happen is we're going to get x minus 5 equals 0. So x equals 5 is it's not the answer to the problem, but it's an important part of it. You have x plus 3 equals 0, x equals -3. And even if you don't know how to do this, the graphing calculator will bail you out of this problem anyway. Okay. All right, get your calculator out and I'll show you exactly what I want you to do. And then you'll be able to do these problems really easily. So you're going to graph the left side of this equation. You got to start off by making sure one side's equal to 0. So just go to y1 and go ahead and put in x squared minus 2x minus 15. And just graph it in a standard window. We may have to adjust the window on this, but just go zoom 6 like we've done all semester. Okay. Now, this is a parabola. Okay, I hope that you know that. Well, the thing is on this, notice that x equals -3 is this x-intercept right there. X equals 5 is this right there. Now, what you need to do on this, you don't really on the final, you don't have to go through and sketch this graph, but I'm going to just sort of put this on here so I can show you what the mathematical meaning of this problem is. Okay, so the idea is if you have less than, or if you have less than or equal, like we're going to have on the next problem, all you're doing is you're looking at where the graph is below the x-axis. Okay, and if we can figure out where it's below the x-axis and write that in interval, we have the answer to the problem. So if you look at this problem, it is below the x-axis in that region right there. Okay, what are the two numbers that you're between? -3 and 5. So your answer is the interval -3, 5. That's how you write your answer. It's interval notation. It's not a point. It's just what you're doing is on these problems graphically, if it's a less than problem, you're looking at graph it on your calculator. Where is the graph below the x-axis? And you name intervals with x values like that. Okay? All right, so it's pretty easy to do. You guys got your calculators. You can graph correctly on your calculator. You should be able to do these problems with ease. Okay? All right, this one, step 1, we're already got 0 on one side. So go ahead, let's just do this one together. Graph that left side on there. Okay? So just go ahead and go to y equals. You can type over what we had on the last problem. So this is x squared plus 10x plus 16. Just do a standard window, zoom 6. You don't have to see the entire parabola, but if you do a standard window on that, you'll be able to see that entire parabola like that. Okay? All right. So let's go ahead and do what we did on this problem. Go ahead and factor this. So this one is going to factor as x and x. What are you going to use for 16? 4 times 4, or is 2 times 8 better? 2 times 8. Good. Okay, because we can get 2 and 8 to add up to 10, so we get that. Okay, so that just gives you x plus 2 equals 0, x equals -2. You have x plus 8 equals 0. That gives x equals -8. Okay, now the calculator is going to show that anyway, so really what we would need to do on this is just kind of put that in the calculator. And those numbers, this is -8 right there. This is the intercept -2, so that's what factoring did. Okay, so what we're doing is this is a less than or equal to problem. So again, we're looking at where are we below the x-axis. So what do you think the answer is? Between where and where? Okay, now, do I need to use a bracket on the -8 or a parenthesis? What do you think? Bracket. Why bracket? because it has equal to in the original problem, right? And we learned that before. So you say bracket -8, bracket -2. So you have to pay attention to that little detail. So see that first problem, number 25, we use parentheses because there wasn't the equal to sign on there. Okay, so see if you can graph these on the calculator. That's the way to learn how to do these. If you're going to take like calculus, one day in a couple of semesters or something, you work with these kind of inequalities all the time. We do them a little bit more technically in that class, but basically if you can visually understand what's going on in the problem, college algebra, that'll get you to a good start, okay? Okay, now let's go to 28. So what do you suppose the first step on 28 is? One side equals 0, right, good. So get rid of the 12x, and you can do that in your head if you want to. You don't have to write the step out, but you're going to have x squared minus 12x plus 35 is greater than 0 like that. Okay, now we're going to go ahead and factor this. All these problems are going to be designed so they factor. Okay, so we're going to have x and x. What do I need to use for 35? There's only two possibilities. 1 times 35 and 5 times 7. What's the right one? 5 times 7, good. Okay, how do you make 5 and 7 add up to -12? What? They're both negative, thank you, very good. Okay, all right, again, you can do this in your head. X minus 5 equals 0. X's 5 is going to be an x-intercept. X minus 7 equals 0. X equals 7 is going to be an intercept. Okay, now just go to your calculator. Okay, and let's kind of see what we got going on this. So don't put in the original problem, put in, after we got a side set equals 0, that's what you want to put in. So we're going to graph x squared minus 12x plus 35. If I do a standard window, you might not see the whole thing. That's good enough. Okay, so I'm just going to kind of look at that. Sometimes you have to adjust your window a little bit on that. So what's going on this problem then is this is the 5, and then that's the 7 like that. Okay, now remember this is a greater than problem. So what makes more sense, looking at what's above the x-axis or what's below? Above, does that make better sense to you? Greater than's big, so it's above. So what we need to do on this one is we're interested in all of the parts of this graph that are above the x-axis, okay? So you have to write this in an interval. So how do you write this thing here? It doesn't have a beginning point. It's going on forever to the left. So how would you write your intervals, that first interval? -infinity to 5, right? Okay, and then how about the second interval? What do you think? 7 to infinity, like that. Good, there you go. That's the answer to the problem right there. Okay, so greater than's above. Greater than or equal to would also be above, except greater than or equal to would have brackets in it, like that. Okay, so it's pretty simple to do if you got, with your technology. That's a pretty easy thing to learn how to do. Okay, everybody follow what we're doing okay? So you'll see one of these on the test. Okay, just got a inequality. It'll say solve the inequality, and it's going to have a power in it. Okay, the first thing on this one is we've already got one side equal to 0. Now when we factor this one is a difference of two squares. 4 is a perfect square, so we go 2 and 2. X squared is a perfect square, so we go x and x. How do the signs go on this? There's not a middle term, so it's got to go away. So what is it? Plus minus, right? Okay. That's a difference of two squares. That's how you handle that situation, okay? So we get 2 plus x equals 0. So we get x equals -2. That's going to be an x-intercept. Okay, then we get 2 minus x equals 0. You can do that in your head. That's x equals 2. Okay. All right, then you just want to put this in your calculator. That's probably the safest way to learn how to do this for now. So we'll graph the original, which is 4 minus x squared. Okay, graph it in a standard window. Okay, like that. So basically, there's your -2. And there is your x equals 2 like that. Okay, so we're dealing with a greater than or equal to. So what do you think the answer is? What part of the graph is above the x-axis? Where to where? No infinities on this one. There you go, -2 to 2. Or am I going to have brackets or parentheses? Good, thank you. Got to have brackets. So that's -2 to 2. Okay, so it's either above or below the x-axis. That's what you do. Okay, that's the fastest way, I think, to teach all students how to do that is just with the technology. Okay, are we good? I know everybody's good with putting everything in their calculator. The factoring is a part of the problem that helps you understand what's going on in the graph better. But even if you don't do your factoring, if you just put it in your calculator, you can usually figure out where it crosses the x-axis. So you can do that without doing that. Okay, so I'm going to kind of jump around. What I'm going to do here the rest of class, I'm going to go over the things that are kind of the biggest things that I see. I'm going to kind of jump around here and there. If we go back to page 1, I want to go through and remind you of how to do 6 and 7. I'm not going to do anything with the quadratic formula or factoring because we just did a bunch of stuff with factoring quadratic equations. So I'm not going to do anything with quadratic formula. But these problems, we hadn't done this in a long, long time, this class. So you'll see one problem that's an equation. We call this a rational equation, and we'll kind of look at that. The idea with these kind of problems is to make all of the denominators go away. That's a general rule of thumb. If your equation has fractions, get rid of all the denominators. On this very first problem, the first thing that you want to do is you want to factor that denominator because it does factor. That's a difference of 2 squares. So that would be x plus 2 times x minus 2. And this was supposed to have an equal sign in it. That you need to add an equal sign right there because otherwise the problem is nonsense. Okay, so that's supposed to say equals 1 over x minus 2. Okay, now, how do you make all this stuff go away? Well, the way I look at it is like this. If I'm going to get rid of an x plus 2, well, I need to multiply by an x plus 2. But that's not the only thing I need to get rid of. I also need to get rid of an x minus 2. So what I'm going to do on this problem essentially is this. So I'm going to multiply both sides of the equation by x plus 2, x minus 2. Okay, and you can do some of this in your head. I think the safe way to teach students this is just to carefully write down the next step so that you can easily see how things cancel. So I'm just going to write down the 3 over x plus 2, and I'm doing a distributive property, so I'm going to multiply that by x plus 2 times x minus 2. Okay, I'm going to show that step. Okay, then I just bring down the rest of the problem. I got the minus sign. I got 2 over x plus 2, x minus 2. And again, I'm doing a distributive property, so I'm multiplying that also by x plus 2, x minus 2 over 1 like that. Okay, and then the right side, I've already got that kind of put together. So I think the safe way to do this, unless you're real confident you can handle all these cancellations in your head, is just to write that step out, even though it's a lot of writing. Okay? So now, if you look at the problem, what happens to this part of the problem right there that I just boxed in? What happens? X plus 2 cancels. What are you left with? 3 times x minus 2. Good. There you go. Okay, the next part of the problem, what happens? There you go, good. Okay, so both things cancel. What am I left with? Minus 2, right? Okay, so I got that. Right side, what happens? X minus 2 crosses out. What I'm left with is x plus 2. Okay, now that one doesn't have a power in it, so solving this equation is just going to be kind of getting x on one side. Okay, so if you do this, you would have to do a distributive property here to get 3x minus 6 minus 2 equals x plus 2. Okay, collect like terms, that would be 3x minus 8 equals x plus 2. Okay, now the way that I've kind of been solving equations this semester is just kind of rearranging things. You can subtract x from both sides. I think a good way to do this is bring the 3x down, move the x to the other side, so it changes from positive x to minus x. Leave the 2 where it is, and then move the 8, so the negative 8, when it moves to the other side, becomes plus 8. That's the best way to me when you get at this level of math to be able to do your equations that way. So what you're going to have is 2x equals 10. Then you can divide both sides by 2, so you get x equals 5. Okay, we learned how to do that probably like maybe around the third, fourth week of the semester, somewhere in there. If you look back at your test 1, there were problems like that. The only thing you have to do on this problem is just make sure the denominator, that when you plug that 5 in, it doesn't make a denominator 0. So if you had like a factor x minus 5 in the original problem, then you would have to throw the 5 out. But you don't have that. Your denominators are x minus 2, x plus 2. So if you plug 5 in, it doesn't make a 0 denominator. So that is the answer to the problem. Okay, does that look familiar? I hadn't done that in a long time. Does that look like something you remember doing? Yeah, okay, yeah, we did. Okay. Okay, let's look at this number 7. Number 7 is a little easier. Maybe it's a little less work. You got x over 4 minus 21 over 4x is equal to negative 1. So the idea is you need to figure out what you need to multiply both sides by to get rid of a 4 and a 4x. So what do you think? 4x, is that what you said? Yeah, 4x is good, okay? The idea is if you multiply by x, that will get rid of the x. And if you multiply by 4, that will get rid of the 4s. Okay, now sometimes students will use 16x, which will work beautifully. It's just unnecessary. All you're trying to do is get rid of a 4 and a 4x, so multiply everything by 4x. Okay, so the way this is going to work is like this. You're going to have 4x over 1 multiplied by x over 4 minus, and we're doing a distributive property, so we do 4x over 1 multiplied by, and that is a 21 over 4x in the original problem. Okay, and then this right side is just negative 4x now. Okay, now look what happens. Okay, what happens on the part that I'm drawing a box around? What goes away? 4s, what are you left with? X squared, good, okay. So we've got, take out the 4s, you're left with x times x over 1, so that's x to the second. Okay, all right, good. Okay, how about the second part that I'm drawing the blue box around? What is that? What happens on that? 4x goes away, good, okay. Wipe out the 4x, what are you left with? Minus 21 equals negative 4x. Okay, like that, okay? So what we do now is that's a quadratic equation because it has the highest power of 2. What do I have to do next to solve this quadratic equation? Already talked about that. Get one side equal to 0, right, good. So you could add 4x to both sides, or you do this your head. You just, when you move negative 4x to the other side, the sign changes, so you end up getting this, okay? Now that one will factor, so we just have x and x, Okay, we need to find two numbers that multiply to give 21. So what do you think? 7 and 3. And how do you make 7 and 3 add up to 4? There you go. 7 minus 3 is 4. Okay, and again, from here you can do this in your head. You don't have to write this step. One of your answers is -7. The other answer is going to be +3. Okay, so that's what we call a rational equation. You know, be prepared to do one rational equation on the final. Okay, which one's it going to be like? I don't know. It'll just be a rational equation. Okay, so it's the idea is be able to solve that kind of and work with that kind of situation. Okay, all right. So let's see on the next page, let's go over the logarithmic equations. Logarithms are kind of what we've been working on the last couple of weeks. So you'll see on the final, you'll see one logarithmic equation. I'm not going to tell you which one it looks the most like, but you know, these are probably three important situations to do. So when you're solving a log equation, the first thing that you always want to do is you want to get a log isolated on one side of the equation. Okay, it's got to be all by itself. So in this particular problem, number 8, you don't want that 10 to be there. You want just the log to be all by itself. And you can do this in your head if you want to, or you can show the step. You're really just subtracting 10 from both sides. So that'll give log base 2, 2x minus 3 is equal to 4. Okay, like that. So you always want to try to get all of your logs together and isolate it. Okay? All right, step 2, write the log in exponential form. Okay, so you got to know what I'm talking about by that. Okay, that's what I was helping you back, Christian, I think, today in class. So how do you write this in exponential form? You say something to a power equals something. So how does that go? 2 to the 4th equals 2x minus 3. That's what exponential form of a log is. You change that. That's the first thing we learned about logs. You take that 2 raised to that power equals that, and then that equation right there, if you can do that, that will be an easy equation for you to solve, seriously. So what we get is 16 equals 2x minus 3. And then from here, you could add 3 to both sides. Kind of running out of room there, but you would end up having 19 is equal to 2x. Then you can divide both sides by 2. So you would end up getting 19 over 2 is what x is. So that problem right there is pretty simple. It's isolate the log, write in exponential form, solve the equation. So that's kind of a 3-step process, okay, like that. Okay, that exponential form is kind of the key thing that you want to be able to do. Okay, now the next problem, when these next two problems, what you have to do on these is you have to go through and you have to know a couple of properties. So there's 2 properties that I want to remind you of, and they go like this. One property we learned, like if you do the log base b of x minus the log base b of y, that's the same as the log base b of x over y. Okay, that's one thing that we looked at when we were looking at properties of logs, I think last week, is we learned that the log of x over y is you subtract the 2 logs. The other property that we talked about is if you have a log base b of x plus a log base b of y, that will be log base b of x times y. Okay, like that. Okay, those are 2 things that we learned there, and those 2 properties are going to tell you what you need to do to solve this problem. So if you have more than one log in your problem, you need to try to use properties to put them together. So anytime you have 2 logs subtracted, you put these logs together like this. You say log base 3, x plus 12 over x plus 4 is equal to 2. Okay, so that's what you need to do in the problem. You have to put it together like that. Okay, so we've done that. That's the additional step on this problem. And then it's the same, from here it's the same as the last problem. You write this in exponential form. So exponential form, you're going to say this number to that power equals that whole expression. Okay, once you put that in exponential form, the logarithm is not in your problem anymore. So you just say 3 to the second is equal to x plus 12 over x plus 4. Okay, got to be really solid with writing logarithms in exponential form. And once you do, then you're going to see an equation that you've seen before. Okay, this is an equation, 3 to the second, of course, is 9. So you've got that. Now it's a rational equation. So what do you need to do to both sides of the equation? You don't want that fraction there. So how do I make the fraction disappear? Multiply by x plus 4. Good. Okay, so multiply both sides by x plus 4. That'll wipe that out. And then once you get to this point, you're going to have a pretty familiar equation. This is going to give 9x plus 36. Okay, the right side's going to be x plus 12. Okay, now it's pretty standard. Okay, you can rearrange. I'm going to do like this. I'm going to bring the 9x down. When I move the x to the other side, it changes from positive to negative. I'm going to leave the 12 where it is. When I move the 36, it'll change from positive to negative like that. Just kind of move and rearrange. So this will be 8x equals negative 24. Then you divide both sides by 8. So you end up getting x equals negative 3 is the answer to that problem. Okay, so there's a log property going on in that problem that you have to do. But exponential form is going to be kind of a big deal there. Okay, you guys understand what I'm doing? Okay. Remember, the only way you get good at this stuff is you just got to work them out. You just tap tape. You know, and you have to kind of work them out without looking at notes and stuff. That's the idea, right? So this one is 2 logs added. So you put this together by multiplication. Your first step, you're going to say log base 2, x plus 2 times x plus 4 equals 3. So problem 9, we had that subtraction symbol. That's how I knew to put together in the log of a fraction. Okay, now what do I do? Once I get an isolated log, what do I do? Exponential form. So what's your exponential form on this? 2 to the third equals x plus 2 times x plus 4. Now that is a quadratic equation. How many times today has a quadratic equation popped up? You're going to see it popping up a lot in the final exam. So we got 8 here, and then you got to FOIL this, because you got to multiply this thing out. You have to do that. So you have x squared plus 4x, and then you have inside term plus 2x, and then 2 times 4 is 8. So I get 8 equals x squared plus 6x plus 8. That's my quadratic equation. All right, what do I got to do to solve this quadratic equation? What's the next move? Subtract 8 to get one side equal to 0. Good, okay. So we got to subtract 8. Okay, when we do that, you're going to now get 0 equals x squared plus 6x. Now you got to factor. Now don't be a 2 parenthesis person. A lot of times students, when they factor, I always go 2 parentheses. Does this thing have a common factor that comes out? There's an x in both spots, right? So you just take an x out. Or don't do 2 parentheses. Just take the x out. That would leave you x plus 6. Okay, like that. And then you're going to get 2 answers to the problem. Okay, and let me show you a couple things that happen. So you've got these 2 factors, and you have to solve each equation. So if you set x equals 0, that's one potential answer. If I set x plus 6 equals 0 and solve that equation, that gives x equals negative 6 as a potential answer. Okay, now I stress potential answer because of one other thing you got to check on these log problems sometimes. So here's kind of what happens. When you check the answer to any equation in algebra, what you have to do is you have to plug into the original problem. So if I was to go through and check this, if you plug 0 in, go back to the original problem, you would have log base 2, 0 plus 2, plus log base 2, 0 plus 4 equals 3. You just got to make sure there's no problem with the logarithms. This would be log base 2 of 2 plus log base 2 of 4 equals 3. So there's no problem with doing a log of a positive number. The log base 2 of 2 is 1 because 2 to the first is 2. The log base 2 of 4 is 2 because 2 to the second is equal to 4. Remember, the answer to a log is that power. So 1 plus 2 is 3, so that one works out beautifully. So that is an answer, is x equals 0. But look what happens when I plug the negative 6 in. If you do, go back to the original problem, you'd have log base 2 of negative 6 plus 2 plus log base 2 of negative 6 plus 4 equals 3. You would end up having log base 2 of negative 4 plus log base 2 of negative 2. You guys remember what's wrong about that? You can't do a log of a negative number. You cannot do logarithms of negative numbers, so negative 6 is not an answer. Okay? You cannot do logs of negative numbers, so don't give up once you get to the two answers, 0 and negative 6. You got to verify them. Okay? So we talked about that a lot in class when we were going over the section on logarithmic equations. Okay? All right, so that's how you handle log equations. That's the basic idea on that. That's what you need to do. Okay, let's go ahead and take a break here till 1 o'clock. And then we'll kind of jump around and we'll get through as many of these things as we can. You might, during break, want to just kind of look over the handout and see what kind of things jump out at you the most. I kind of think I know where the biggest problem areas are. All right, so let's go ahead and start with 30 and just kind of see what you all remember on this. So this is a polynomial function. We want to be able to find the degree. Just lost my voice. So let me get my throat cleared here. Excuse me. So we got to do the degree, the leading coefficient, zeros and multiplicities, see if it touches or crosses, y-intercept, and then graph. Now, back when we did this kind of problem on a test in this class, I didn't let you use your calculator because I wanted to see if you could piece together the graph without a calculator. I'm going to show it that way, but I can't think of any single reason why a student on a final, if we let you use a calculator, wouldn't, how can you get it wrong? Seriously, okay? Really? Okay, so let's see what you all remember on this. Okay, first of all, let's look at the degree. Does anybody out there remember what you have to do to find the degree of this thing? What's that? Just kind of add up all these things, those exponents are called the multiplicities. So the degree, what we do is we just do 2 plus 3 plus 4, which would end up being 9. And automatically, if you have an odd degree, anytime you have an odd degree, think about what you learned about how the graph looks. So one of these two. Okay, odd degree, it looks like this. Even degree, it is either up or down. So the graph is either going to look like that or the graph's going to look like that. Okay, so we got that. That's how you find the degree. Okay, the leading coefficient. Now, when you do the leading coefficient, that means if you multiplied all this mess out, that would be the number in front of the highest power. So that's what it is it's the number in front of the highest power. So the way you do this is you take the coefficient 1 and raise it to the second. You have to pay attention to that multiplicity on that. Take the coefficient of the next one, which is also 1. Okay, usually it is 1. And then that's the third power, and then take the coefficient of the other factor and raise it to the fourth power. Well, that's just 1, so your leading coefficient on that is going to be 1. And what that tells us then is if the leading coefficient is positive, it tells you the graph looks like that. Okay, so that's kind of partially the purpose of going over that, is to see what the graph does. Okay, all right, now the next thing we're going to do is we're going to do the zeros. Now notice this thing's already factored, so you can do this in your head. You have x minus 5 is a factor, so that gives x equals 5. Its multiplicity is the 2, like that then. So that's the power is that. And you can do all this stuff in your head. Okay, so that would be a multiplicity of 5, a 0 of 5, multiplicity of 2. Okay, the next one you have is x minus 1 equals 0, so that would give x equals 1. That would have a multiplicity of 3. So that would be the second kind of key thing you have. Okay, and then from there, the last factor you have is x plus 4. So that gives x equals negative 4, and that has a multiplicity of 4. So all that stuff right there you can do in your head. It's in a factored form. Okay, so that's what that means. Okay, D, let's see if we remember anything about the touching and crossing stuff. The touching and crossing is all about the multiplicities. Does anybody remember how you can tell if you touch the x-axis based on the multiplicity? You got it backwards. It touches if it's even, crosses if it's odd. Okay, so that's something you want to kind of remind yourself of. So anytime you're even multiplicity, you're going to touch. Okay, if it's an odd multiplicity, you're going to cross. Okay, so part D says just make that determination. So at the 0 x equals 5, since you have an even multiplicity, you're going to touch. Okay, at the 0 x equals 1, you have an odd multiplicity of 3, so that means you're going to cross. Okay, and then the next thing is if you're at x equals negative 4, you have an even multiplicity of 4, so that means you touch again like that. Okay, so that's how you remember that. I just got to remember that simple rule on there then. Okay, and then the next thing we're going to do is we're going to do a y-intercept. Now, when you find a y-intercept, you always do the same thing. Anybody remember what you do to find a y-intercept of any function? Make x equal 0. Good. So what you do is everywhere you see a x, you're going to plug in a 0. Okay, and you'll have to use your calculator on this. 0 minus 5 squared, 0 minus 1 to the third, 0 plus 4 to the fourth. So I'll just go back to the original problem. That would end up giving negative 5 to the second times negative 1 to the third times 4 to the fourth. That would end up giving 25 times negative 1, and 4 to the fourth is 256, like that. Then you just have to take your calculator. Now you can do the calculator on the whole thing if you want to. And you're going to see what that is on your graph anyway, because you can see if your graph's right because you'll have your graphing calculator anyway. So I got 25 times negative 1 times 256. Whoops. That'll give you the y-intercept, which, well, I put it in the wrong place. What am I doing? So it's really just negative 25 times 256. So that's going to give me negative 6,400. Okay, so that means the answer to the y-intercept is you write that y-intercept as the point 0, negative 6,400. Okay, like that. Okay, so that's how that goes. Now, those are just kind of review of the key things. And then let's go ahead and let's just do this then. Now, this is how I taught you all how to do this. When you actually draw your graph, I was trying to get you to draw graphs without just pressing buttons on your calculator, because you need that knowledge for higher math. If you just press buttons, you'll get the problem right on your final. But the idea is basically really all we got to do is look at the things I underlined in blue. You have a y-intercept of 5, or you have a 0 at 5. So I just taught you to put a dot there, and it touches, so I'm going to put T for touch. Okay, then you had x equals 1. You had an odd multiplicity, so I'm going to put C for cross. And then we had the other 0 was at -4. Okay, and that was an even multiplicity, so I'll put touch there. Okay, the other thing we have is a y-intercept, so just put a dot and just label it. Okay, it's 0, -6400. You don't need to scale that y-axis because it doesn't matter. So the way I taught you all how to do this then was basically like this. The endpoint behavior, since it was a 9th degree polynomial, the ends of the graph go like this. And then you just have to kind of, wiggle through these points. So you're going to go to -4, but you're going to touch, which means you have to change directions. Then you're going to go through the y-intercept. Then you're going to cross through that 0. Well, you got to change directions somewhere. Then since you touch, you got to change directions again. So that's basically what that graph looks like. And you would be better off probably to do the problem without your graph, because the graphing calculator, you'd have to set your window and everything on this. But go ahead and just put the original problem in your calculator. You can't go wrong on this problem. Okay, that's the way I taught you all how to do that. So if you just go back to the beginning and put in x minus 5 to the second, and then x minus 1 to the first, or no, x minus 1 to the third, and then finally x plus 4 to the fourth. Now, when you do the window on this, if you do a standard window, you're not going to see this full graph. So what I would suggest that you do, -10 to 10 on x is good. That will, all those x-intercepts fit in there, but you had that y-intercept of -6400. So what I'm going to choose to do is pick a number a lot bigger and smaller than that 6400. I don't know what's best, but I'm going to try -20,000 to 20,000. You can scale that by whatever you want to. I think 5,000 is reasonable. Okay, but then if you kind of get that set up and do your graph, okay, well, it kind of resembles what we did by hand. Okay, so the thing about this is the sketch I made is not as accurate as what the calculator is giving, but you can certainly see the touching, the crossing, and the touching there. So you can check this on your calculator. Okay, that's kind of the idea of how you would want to put that together. So any questions on that? Do you guys remember some of the details about zeros, multiplicities, that kind of stuff? Multiplicity is when it's in a factored form, it is these numbers right here, 2, 3, and 4. So we would say we have a 0 of 5, multiplicity of 2, and if the multiplicity is even, it touches. So we would say we touch at 5, and then the multiplicity of 1 would be 3, and so forth. That's all that is, okay? Anybody else have a question on that? Okay, all right. Next one we're doing backwards. Okay, so this one is basically giving you this information. You have a degree of 6 that has a negative leading coefficient. When I look at those two pieces together, if it has a degree of 6, an even degree looks like this, like touchdown, or like this. Which one is it going to look like if it has a negative leading coefficient? It's going to go down, exactly. So those pieces of information right there, that already tells me that the graph is going to look like that. Okay. Now what you're doing is you're putting this all together. So if you kind of put this together, you have a 0 of 8 with a multiplicity of 1. So when you start building your function, this one you're making the function. Well, if you have a 0 of 8, then what do you have? You have x minus 8 as your factor, and then the multiplicity would tell you that exponent is 1. Okay, and that would tell you that you're going to cross the x-axis at 8 because that's an odd multiplicity. Okay, then the next thing it says is you have a 0 of -1 with a multiplicity of 2, so that factor would be x plus 1 to the second. Opposite sign when you do that, and then this would touch like that. And then finally, I guess you get one more 0 I gave you on this is you have a 0 of 3 with a multiplicity of 3. Okay, so that would end up being the next factor would be x minus 3 to the third. That would mean you cross like that. So see what you're doing on this, you're doing this backwards. I'm giving you the zeros and multiplicities, you're building the function, okay? Now, there's a couple of things that are kind of important on this. The leading coefficient is negative. If you look at your leading coefficient right now, I mean, what you're really always just doing on this is you're just looking at the numbers in front and raising it to those powers. Okay, right now, if you do that, that's a positive number. I need to make this negative, so what I can do is I can put a negative there for that leading coefficient. Okay, I have to put that there, okay, because if the leading coefficient's negative, you got two choices. You could make one of these x's negative, but you don't want to mess those things up because that'll mess up your zero. So just throw one in the right in the front of everything, and that forces your leading coefficient to now be negative, right? Okay. Then I don't know if the handout you guys have, does it have positive 216 on it or negative 216? Does it have negative? Okay, because I had to correct this problem earlier. Okay, so guess what? That's your answer. The only thing you really have to do is just check to see if that y-intercept's right. Okay, how do you find an a y-intercept? You plug 0 in for x. So I'm just really checking this. So if I do negative 0 minus 8 to the first, 0 plus 1 to the second, 0 minus 3 to the third, I'm going to get negative 8 times 1 times negative 27. Okay, and that would give you, if you did that on a calculator, it'd give you negative 216. Okay, now I tried to do a little bit of that in my head, but I'm just doing negative 8 to the first, 1 to the second, negative 3 to the third. Okay, but the point is, you get the y-intercept you're supposed to get, so that would tell us that that is the answer to the problem. So what you're doing is in reverse, taking that information and putting that together. Okay, now you're also supposed to graph this. Again, you could graph this on your calculator. I'm going to go ahead and just kind of remind you how you can do this without a calculator. So what you would do is we need to go out to 8. Okay, so there's 8. We need to also look at 3, and we also need to look at negative 1. And then we got that y-intercept. So if you're doing a sketch of a graph, you just kind of do this. At 8, we said we cross because that was an odd multiplicity. At negative 1, we touch because that's an even multiplicity. At 3, x equals 3, we cross because that's an odd multiplicity. Okay, and then your y-intercept, just put a dot. It doesn't matter where it is. It just needs to be down, negative 216. So we'll just kind of write that in as the y-intercept like that. Okay, and then again, what we had in the beginning of the problem, you were given that the degree of this polynomial was 6, and you had a leading coefficient that's negative. That tells you the graph goes like this. So when you begin to put this together, I'm just going to say, okay, I'm just going to kind of put these arrows, then I'm going to loop through everything. So this is going to go like this. It's going to go to the negative 1. If it touches, it has to change directions. Then it's going to have to go through the y-intercept. At some point, it's got to change directions and cross, and then it's got to go like that. So that's roughly what it looks like. Okay, and you don't have to use your calculator unless you feel like you need to check your answer. But on this one, you would want to make your y's pretty big when you adjust your window. You'll get a little bit more accurate graph on your calculator, but that's good enough. That's what I'm trying to get you to do. Okay? All right, you guys, that coming back to you. We haven't done that in a long time. Okay, all right. Okay, now I kind of picked out some problems that we hadn't done in a while and that are problematic. Piecewise functions are problematic for students for, I don't know why. I think a lot of it's the approach students make on this. I'm going to do this 32 real quick, and this is super easy. You're given a piecewise function, And what happens on this is a piecewise function is two pieces. So if x is less than 0, you plug into the function 4 minus x. If x is greater than or equal to 0, you plug into the other functions, 3x minus 4. So all you got to do on this problem is know which one to plug into. That's it. Once you figure out which to plug into, it's all arithmetic. So -1 is less than 0, right? So that means you're going to use 4 minus x, okay? So what do? Just plug it in. You just say, plug in the -1 into x, you're going to get 4 minus -1. So that's 4 plus 1, so that's equal to 5. So all you got to do is know which one to plug into, okay? All right, so this one is x equals 0. Now notice there's two pieces. One of them said less than 0. The other one said x greater than or equal to 0. Which one do I use? 4 minus x or 3x minus 4? Yes, because it says if x is equal to 0, that's what we use. So we use 3x minus 4. So we're going to do 3 times 0 minus 4. That's equal to -4. That's your answer right there. So there's nothing to that if you understand what a piecewise function is showing you. Okay, the next one, 2. Now 2 is greater than 0. So which function do I use? Second one. They use it again. So I use 3x minus 4 again. I just plug in the 2. So I do 3 times 2 minus 4. That's 6 minus 4, so that's equal to 2. Okay, you want to know how to do that. That's a super easy interpretation problem. Okay, I'd hate to see anybody miss something like that because it's arithmetic and it's knowledge of where the numbers fall on the number line, which one to plug into. Okay, graphing a piecewise function. This is such a problem, like in my calculus class. I don't know why, but what I recommend that you do is I recommend that you make tables of values. Okay, this is something we probably did on your very first test. So what we're going to do is the first piece is this function. And what I would recommend you do is just make a table of values. We have x values and y equals x squared minus 1. Now, you can't just pick any number you want for x. Okay, what does the problem say? It says you can only pick numbers less than 1, right? You still want to start at 1, but since there is not an equal to bar on that, that means that when you plot this point, it's going to be an open bubble. Okay, then start picking numbers that are less than 1. 0 is a good choice. -1 is a good choice. -2 is a good choice. The more you pick, the more accurate your graph is. Okay, so notice I picked things at 1 and things that were less than 1. But notate that you have an open bubble on the 1 where it comes to an end. Now we just do this. 1 squared minus 1, that would be 0. You do 0 squared minus 1, that's -1. You do -1 squared minus 1, that would be back to 0. Use your calculator if you have to. Then you do -2 squared minus 1, that's 4 minus 1, so that's 3 like that. Okay, so that would be like your first table of values, and we'll do the graphing after we do these table of values. Okay, do you guys understand why I picked 1, 0, -1, and -2? Does everybody understand that? You can't just pick any old number you want to. Okay, now we get to the next one, we're going to do another table of values. So we have x values, and then we got y equals 2x minus 5. Okay, tell me what kind of numbers I need to use for x. Just describe it in words, in a sentence. Yeah, which means start where? Start at 1, and then do bigger than 1. Now, at 1, do you think we'll have a solid dot when we draw the graph or an open one? Solid. Why? Because it's got the equal to bar. So make a note to yourself that that end point is going to be solid. Now just pick whatever numbers you want to that are bigger than 1. Just keep it simple. I'm just going to do those numbers there, and I'm going to plug into 2x minus 5. So I do 2 times 1 minus 5, that's negative 3. I do 2 times 2 minus 5, that's negative 1. I do 2 times 3 minus 5, that gives 1. Okay, so it's arithmetic. It's knowledge of what X values to use and then the arithmetic, how to plug them in. Now, the next thing you do is you just plot these points. Okay, so let's go ahead and let's construct our graph then. So let's see, I'm just going to go out to about 3 and maybe out to about negative 3 like that, and maybe up to 5 or something, and maybe down to negative 5 like that. Okay, so the next thing you have to do is you just got to plot these points. So I'm going to take the points in my first table of values, and I'm going to plot them. I've got 1, 0, but use an open bubble. That's important. Then I've got 0, negative 1. Everything else is solid. You've got negative 1, 0. That's a definite point. You have negative 2, 3. That's a definite point like that. Now, what students do wrong all the time is they want to go in both directions. I think I put that point in the wrong place. So I've got negative 2, 3. You only go to the left, okay, because this problem said this is the graph when x is less than 1. So it's that way. Don't go any further than that. So you have that, okay? Now you go to the second table of values, just plot the points. You've got 1, negative 3 with a solid dot. You've got 2, negative 1, and you've got 3, 1 like that. Now, this said this is the piece for x greater than 1, so you only go to the right. You don't draw the whole entire line. You only go to the right, like that. Now, remember, way back when we started talking about functions, we talked about the vertical line test. Does a vertical line always go through one point on this graph? Always, no matter where you are. Yeah, even there. That's why that's open and that's solid, because it only goes through that point. So that's a function. So do not draw these things in both directions. That's totally wrong. That's the most common thing that I see students do incorrectly on the problem. But you'll do this work with piecewise functions, basically know how to evaluate one, like I did in problem 32, and know how to graph one. Graph, table of values. Okay, table of values, plot points, that's it. Okay, does anybody have a question on that? Okay, all right, now again, you got to work these things out with looking at notes if you're going to learn how to do this and get this solid for testing purposes. Okay, all right, again, I'm picking out the problems that I feel like are going to be need the most review for the rest of class here. So let's jump to 38. Now, like 36 and 37 are the same idea as 38. So 38 will kind of serve as a review for those two problems anyway. Okay. All right. So first of all, okay, you'll see a problem that's pretty similar to this. You've got a quadratic function. So this is a quadratic function. So what does the graph of a quadratic function look like? It's a parabola, right? It either goes up or it goes down. And you can tell by looking which one it does, whether it goes up or down. All you got to do is look at the number, the coefficient of the highest power. If that is negative, that means the graph goes down, which means you have a maximum. Okay, that's what that means. If that number in front of x squared was positive, then the graph would open up, which would tell you that you have a minimum. Okay, what if you don't know that? You could graph it on your calculator, and the graphing calculator would certainly tell you what it does. Okay, but I want you to know this stuff without a calculator. Okay, so I know automatically that this graph is going to look like that, so it's going to have a max. That's how we know. You don't have to show any work on that. It's just knowledge that we have a maximum. Okay, all right. Now, vertex. There is a formula I gave you all to help you find vertex. Anybody remember what that is? What? You're close. Negative b over 2a. Now, you guys will be given some formulas. After class, I'm going to post an email to you guys which formulas you're given. I didn't quite have time to put that today, but I know you'll be given that negative b over 2a. You just got to know what to do with it. I'll give you the quadratic formula. There's some other things, some logarithm stuff, but you just have to know what to do with it, okay? So first of all, in this problem, make sure that you get this in the right form. Rearrange everything. The x squared should come first. The x term should be in the middle, and then the constants term should be there, okay? So now we know that a is -6, and we know b is 250. We know c is 1500, but it doesn't matter. C doesn't have anything to do with the vertex. So when we do negative b over 2a, we just do negative of b is 250, over 2a, a is -6. So that would give me negative 250 over negative 12. If you get a decimal, I'm okay with just kind of rounding off the decimal. It's kind of hard to sometimes make these problems up so that they're whole numbers. So let's see, this would be a positive, so 250 divided by 12 would be about 20.83. I'll round it off to 2 decimals like that, okay? So remember, when we're getting a vertex, the vertex is going to have an x value and a y value. So the next thing I got to do is I got to find the y value. So I just plug in to the function that 20.83. Okay, you can do this totally on your calculator. You go back to the original problem and do 1500 plus 250 times 20.83 minus 6 times 20.83 squared, like that. And then you just do that on your calculator. You don't have to write any of the steps of your arithmetic. You can just put it in. So 1500 plus 250 times 20.83, and then minus 6 times 20.83 to the second power. Okay, I think I got everything in right there. So yeah, that would be about 4,104.17. And I'm okay with decimals. So the answer is the vertex would be, it would be this basic point. So the answer to the problem would be the point 20.83, that's the negative b over 2a thing, and then 4,104.17, that is your vertex. You write your vertex as a point. You found both the x and y values like that. Okay? All right. So does that serve as a good reminder of how to find a vertex? Negative b over 2a is what you got to know. That's the simplest way to learn how to do that. Okay? Now, if we read the problem, we want to kind of write, what does this thing mean? So the 20.83 is the x value. What does it say about this? It says that's how many stereos you have. So basically the vertex would say you have 20.83 stereos. That's the context of the problem. And then the function value is the cost. So basically the vertex is, this is the cost. So really what this vertex means is, it means when you have 20.83 stereos, that costs, the cost of that is 4,104.17. And this right here is the maximum cost. Okay, so that's the idea. What that is that's how many stereos get produced that cost the most. That's what that basically means. Okay. Okay. Question about the vertex? Are we feeling okay with that? Shake your head or something. Look at me. Smile. Thumbs up. I don't have a clue. All right. Okay. All right. Now the next problem. It says find the number of stereos, which is x, when the cost is 2,600. So let me just kind of start this way. We're just going to write down the function. F of x equals 1,500 plus 250x minus 6x squared. Now you have to plug this in the correct way. The cost is the 2,600. The number of stereos is x. So you got to solve an equation on this. So what we're going to do is replace the f of x with 2,600. So we get the equation 2600 equals 1500 plus 250x minus 6x to the second. Here we go again. One of the things I said, the most common thing that'll show up in this test is a quadratic equation. I've already solved probably 5 or 6 of them in here. Okay, so what do you do when you solve the quadratic equation? Well, you got to get one side equal to 0. So we definitely need to do that. And I'm just going to kind of rearrange this. So I'm going to put the negative 6x squared and then the 250x, and then 1500 minus 2600 is 1100. Okay, so now we can use this as an opportunity to review the quadratic formula. You don't want to mess with factoring out. The numbers are too dang big. Okay, so you get A is negative 6, B is 250, C is negative 1100. Okay, so we're going to throw this into the quadratic formula, which you will be given, I think, for higher math classes. If you're going to take calculus or something like that, no teacher will ever give it to you ever again because it's such a fundamental formula. But in this class, we're going to do it. Okay, so what we do is we do negative, and this is one of the things I recommend when you plug into the quadratic formula. Use parentheses where all these variables A, B, and C go. If you do that, then you're less likely to make any arithmetic mistakes. So kind of build a framework like that, and then just start plugging everything in. So we got B is 250, so the B's go there. A is negative 6, so one goes there and one goes there. And then the C is negative 1100, so that goes like that. Okay, and this may turn out whole numbers, may turn out to be decimals. We can use our calculator to kind of help us with this. So we get negative 250, and then what I would recommend you do is just take your calculator and do what's under the square root and get that taken care of. So I'm going to do 250 to the second, subtract 4 times negative 6, times negative 1100, and that'll give me 36,100, and then that's all over negative 12 like that. Okay, now you're going to get 2 answers on this problem. So what we have to do is we might as well right now, we can go ahead and do this square root if we want to. So if I do the square root of 36,100, it's either going to be a decimal or a whole number. That's a whole number. You know what that means? It means this thing would have factored. But I wouldn't factor something like this. This number is too big. So what we're going to do is we have negative 250 plus 190 over negative 12. So you get your 2 answers by doing this. You do 2, that should be a plus minus, negative 250 plus 190 over negative 12. We'll do that on the calculator. And then we'll also do negative 250 minus 190 over negative 12. We'll do that on the calculator, okay? All right, and if you do this, I usually do this in 2 steps. So negative 250 plus 190 gives me this. So this is really negative 60 over negative 12. That's equal to 5. So that's basically 5 stereos is going to produce that cost. Then I do the other one like this. I do negative 250, subtract 190. That gives negative 440 over negative 12. This one will probably be a decimal. So if I just take that number and divide by negative 12, I'm going to get, the other answer is about 36.7. We can round it off like that. Okay. So that's quadratic formula. So somewhere in the test, you'll have to do quadratic formula, okay? So that's kind of how you go about doing that. That kind of serves as a review of a vertex and that kind of thing like that. Vertex, finding if something's a max, all those kind of pieces like that. Yeah.
Does that mean it would be like in between 5 and 36 stereos produced, or is one of those numbers?
What it would mean on this problem is really these are really what they're going to be is they're going to be x-intercepts. 5 and 36.7 are x-intercepts. So if you're less than 5, you're going to end up having, it's going to be below the x-axis, so your cost gets into negative amounts, which makes no sense. So really what would happen in the context of this problem, you would only have positive cost between 5 and 36.7 because those are x-intercepts. And again, the parabola is going down, so once you're beyond those, your cost is negative, okay, which we don't have. So that wouldn't really have any meaning in the context of this problem. Okay, all right. Let's go to the next page and let's review 39. This was real important you know how to do this. Now, so what you're given on a problem like this is a graph of a rational function. So our goal on this problem is to be able to write the equation of that function. Okay, so we did this. Now, what we spent a lot of time on was just, I gave you the function, you did the graph. Now I'm just doing this in reverse, okay? So first of all, on a problem, it'll be pretty clear what the vertical asymptotes are. Those are the dashed vertical lines where you have breaks in the graph. So one of these occurs at x equals -3. The other vertical asymptote occurs at x equals 2. So when you build the equation out of this, that's going to be incredibly important that you know what those are, okay? So those are your two vertical asymptotes. Your horizontal asymptote is the horizontal line that's dashed like that. And that looks like that is going through y equals 3. So you got to identify those asymptotes right there. That's real important, okay? All right. Now let me go over this terminology on parts C, D, and E. Okay, this is easy, but you got to study and review how to do this. So if x is, that arrow says you're moving to -infinity. So all this means is if the graph is going forever to the left, what's happening to my y value? My y value is getting close to what number? Not 0. 3, there you go. That's what a horizontal asymptote does. It tells you if you go to infinity, the graph levels off there, okay? Now the next one, we're going to positive infinity. So let's look at the graph going forever to the right. So if you go forever to the right, what does the y value get close to? 3 again, right? Okay, so that's what that is going to do there, okay? Now, part D, we're looking at when we have this negative, that means we're to the left of 2, okay? So what we're doing on this, and we're just barely to the left of 2. You have this vertical asymptote at 2, so if you're barely to the left of 2, you are way up here. And way up there is positive infinity. So the answer to that would be positive infinity. That just means if you're barely to the left of 2, the graph is getting extremely high. That's what that means. Okay, the next problem says if you're barely to the right of 2, and barely is the key. So if I'm just barely to the right of 2, where is the graph? It's way down. So the answer to that's negative infinity. Okay, so but that's just kind of interpretation of what's happening to the graphs around the asymptotes. Okay, all right, part E. This one has the minus, so that means if we're barely to the left of -3, we want to look at where the graph is going. Okay, look at -3, look at that vertical asymptote. If you're barely to the left of -3, where is the graph? It's positive infinity, it's going up. Okay, and then the last thing here is if you're barely to the right of 3, okay, if you're barely to the right of 3, where's the graph doing? It's going down. Okay, so that's negative infinity, like that. Okay, so that's just knowledge of what that arrow and what infinity and all those things mean. That's graphical interpretation stuff. Okay, so now if we look at this, the other important thing is, what are these x-intercepts? Okay, well, you have an x-intercept at 3, 0. That's super important. And then you have another x-intercept at -2, 0. Okay, so these are your x-intercepts. Okay, so we got that. The y-intercept is right here. And it looks like that y-intercept looks like the 0.03, like that then. Okay, all right. So we got all those pieces right here. Now here's the part of the problem that you have to know how to do. So when we put together the answer to this problem, it goes like this. Okay, you're going to have a rational function. So your function is going to be a fraction. So what happens is the vertical asymptotes come from the denominator. Okay, that's what a vertical asymptote is it's something that makes the denominator 0. All right, go back to your vertical asymptotes. You have two vertical asymptotes. One of them is -3 and one of them is 2. So that means in the denominator, I would have x plus 3 and I'd have x minus 2. Okay, whatever your vertical asymptotes are going to be factors in the denominator. Okay, the numerator is where the x-intercepts come into play. Okay, so it goes like this. So look at your x-intercepts. Your x-intercepts were 3 and -2. So that means in the numerator, you're going to have x minus 3, x plus 2. Okay, you guys understand why I'm doing the signs the way I am? Okay, just opposite, okay? But just remember, x-intercepts are factors in the numerator. Vertical asymptotes are factors in the denominator, okay? So now, what else do we got? Well, the other thing we have is the horizontal asymptote. So the horizontal asymptote, you have to kind of go back to this situation here. If the degrees are equal, this is, you don't need to write this down, I'm just kind of reminding you of something, okay? If the degrees are equal, then remember the leading coefficients would give you that horizontal asymptote. So what we have to do, if we're going to get this horizontal asymptote of 3, that means we got to put a 3 right here. You got to have a 3 over 1 there. That puts in that horizontal asymptote. Now you've got your vertical asymptotes, you got your x-intercepts, and you've got your horizontal asymptote all put in that problem then. You just got to know where all these pieces go. The only thing that you got to do on this problem is see if our y-intercept is correct. So this is probably the answer to the problem. That is probably more than likely your answer. So what I'm going to do is I'm going to check the y-intercept. We had the y-intercept is 3 on this problem. Now it may not be 3. It may end up being just some number close to 3. So when you find a y-intercept, you find f of 0. So we would do 3 times 0 minus 3 times 0 plus 2 all over 1 times 0 plus 3 times 0 minus 2. Okay, look what happens. That would be 3 times -3 times 2 over 3 times -2. That would end up being, what would that be? -18 over -6. That's equal to 3. That's what it was supposed to be. Okay, so that's kind of the idea, is when you study how to do a problem like this, you just got to know. I know you guys can look at a graph and tell what the x-intercepts are. I know you can tell what the vertical asymptotes are because they're going to be pretty obvious with the dashed lines on there, and the same thing with horizontal. The key thing to me that you have to be really cautious about is this, okay? The x-intercepts are coming from the numerator. The vertical asymptotes are in the denominator, okay? And then this thing right here is the horizontal asymptote. Okay, that's kind of doing something reverse. Now, problem number 40 is another example on that. I'm not going through all the details on that, but it'd be done in a very similar way. Okay, all right, well, that's as far as we can go today. Is anybody going to come on tonight? Okay, Daniel, Christian, anybody else? Please come on if you can. Okay, get 50 points, and well, I'll do the best I can to get you ready. Okay, and then we'll do another one on Wednesday. You can come to both unless you feel like you're okay, or if you got, I know people work and have other responsibilities, but please come on if you can, okay? And if you, as long as everything in my house is working, we'll have it. Okay? Last night I had water problem in my house, so I had to cancel. All right, so I'll see some of you tonight then.